A power blip you cannot even see can take a whole production line down for an hour. Half a second. The lights barely flicker. But the PLC running the process loses its place mid-scan. It drops outputs, corrupts the data it was holding, and the line stops. The grid looks steady. It is not. A breaker trips somewhere, a big motor starts across the plant, lightning clips a line, and the voltage sags for a fraction of a second. The fix is a small box called a UPS. In this video, I will explain what a UPS actually is, why an automation system needs one, and the 3 types, so you pick the right one. Let us start with the box. Quick note before we dig in. This is from PLC Simulator, where you can practice PLC control power and the rest of this video free, right in your browser. No install, no hardware. The link is in the description. Click the link in the description to try it free. Now, back to the UPS. So what is a UPS? The letters stand for Uninterruptible Power Supply. It is battery-backed power that sits between the wall socket and your equipment. And it does 2 jobs at once. The first job is ride-through. When the mains dips or disappears, the battery picks up the load instantly, so the gear on the other side never sees the gap. The second job is conditioning. A UPS cleans up sags, spikes, and electrical noise, so what reaches your equipment stays inside spec. Think of it as a buffer. Power flows through it on a good day, and on a bad day, it carries the load on its own until the mains comes back, or until you can shut down safely. That is the whole idea. Now, why does an automation system specifically need one? Because a PLC is not like a light bulb. A bulb does not care about a 5-millisecond dip. A controller does. A PLC scans its program dozens of times a second, and it holds live state, counters, timers, the step it is on in the sequence. Knock the power out for an instant, and that state can be lost or scrambled. So a UPS buys you 2 things. 1, ride-through. It carries brief dips, so the controller never even notices. 2, time. If the outage is real and lasting, the UPS holds long enough to trigger an orderly, controlled shutdown. That protects the process, and it protects data on the HMI and the servers behind it. You put the UPS on the PLC, the HMI, and the control network switches. The brains of the system. The parts that must not just blink off. Here is the part most people get wrong. There are 3 types, and they're not equal. First, standby, also called offline. Your load runs straight off the mains, and the UPS only switches to battery when power fails. There's a small gap, a few milliseconds, during that switch. It is cheap and fine for a desktop PC. Second, line interactive. Same idea, but it adds an autotransformer that trims sags and surges without touching the battery. So it rides out brownouts far better, and the battery lasts longer. This is the sweet spot for most control panels. Third, online double conversion. This one runs everything through the battery and inverter all the time. The mains charges the battery. The battery feeds your gear, always. So there is 0 transfer time and complete isolation from whatever the mains is doing. It is the gold standard for critical PLC and server loads. More expensive, but nothing gets through to disturb the load. Last piece, sizing, so you actually pick the right unit. 2 numbers matter. Capacity, rated in volt amps and watts. It has to be bigger than the total load you're plugging in. And runtime, how many minutes the battery holds that load. A UPS is not meant to run the plant for hours. It is meant to ride out a blip or to give you a few clean minutes to shut down properly. So add up the watts of your PLC, HMI, and switches, leave headroom, then check the runtime curve at that load, and place it on the control brains, not the big motors. The motors can drop. The controller cannot. So here's what to walk away with. A UPS is battery-backed power that does 2 jobs, ride-through and conditioning. Automation needs it because a controller holds live state that a single blip can wreck. There are 3 types, standby, line interactive, and online double conversion. And the right one depends on how critical and how dirty your power is. And you size it by load and runtime, then put it on the brains of the system. Get that right, and a power event becomes a non-event. Now, go make it concrete. If you want to practice PLC control power hands-on, click the link in the description to start free at plcsimulationsoftware.com. No hardware, no install. Subscribe. New video every Tuesday. See you in the next one.